objective 11 and 12 I'm going to do together. It says determine the limiting reactant and theoretical yield. And then number 12, determine percent yield. You need to know your theoretical yield to do that. So combining these, I've got 45 grams of chromium reacting with 25 grams of oxygen to produce chromium 3 oxide. And I'm asking you for 3 different things. What is the limiting reactant? If 22 grams of products are recovered, what is the percent yield? And how many oxygen atoms would be in this actual yield? So let me make this all a bit smaller so I can fit all this on here. And I'll make this a little bigger so you can actually see it. So first of all, I need my balanced equation, which is going to be chromium. It's monoatomic as a metal. Oops. Plus O2, since it's diatomic. And we're told that it's going to be chromium 3 oxide. Let me just find my arrow. So it's going to be Cr2O3. That means for balancing, I'm going to need a 2 here and a 3 here, which will put a 4 here. So now I have to find out what my limiting reactant is. And the only way to do that is to convert both my reactants into moles and find out which one would yield less product. So for the chromium, I have got 45 grams, and chromium weighs 52 grams per mole. So that means I've got 0.865 moles of chromium that I'm starting with. Now, I can't just leave it there. I have to look at how much chromium oxide that would produce. I would get 2 chromium oxide per 4 chromiums, or this amount would actually be cut down to 0.433 moles of chromium to oxygen 3. And in comparison with the oxygen, I guess I better leave it up here. I'm going to need the space. The oxygen is 25 grams with a molar mass of 32 grams per mole. So this is 0.781 moles of oxygen. But again, I can't assume just because it's less oxygen, it'll produce less product. So taking a look at the molar ratio, I get 2 moles of chromium oxide from 3 moles of oxygen. So when I multiply this, I'm actually get 0.521 moles of my product. So my limiting reactant to answer the first question is chromium. The second question then wants to know what would be, if 22 grams of product is recovered, what's the percent yield? Well, I've determined I can only make 0.443 moles of my product. And my molar mass for that, 2 chromium times 52 plus the oxygen at 16 each. So that's going to be 152 grams per mole. So 0.433 moles is going to be a little less than half of that at 65.82 grams. That's the expected yield. My actual yield is only 22 out of that 65.82. So times 100% means my percent yield is right around 33%. And the last question, how many oxygen atoms would be in the actual yield? Since the actual yield is 0.433 moles, that is of my Cr2O3. So I have to triple that because that means there's 3 oxygen atoms in every mole of the product. So we're actually talking 1.30 moles of oxygen, and 1.3 moles of anything is going to contain 6.02 times 10 to the 23rd, oops, try that again, to the 23rd atoms. So this comes out as 7.82 times 10 to the 23rd oxygen atoms.